35. All right, mark this question. It's a tough one. It's a good one. Focuses on the formation of two different salts by reacting sodium hydroxide with sulfuric acid. However, the ratios are important. Note, sulfuric acid is what we call a dibasic acid, meaning that there are two H plus ions, two protons per sulfuric acid. So if there's two protons, then there's two alkalis required to fully neutralize, right? So if I want to get rid of all of the protons, if I want to get rid of all of the protons, then I need to add in twice the amount of alkali to the acid. If I want to get rid of only half the protons, then I would add half the acid to the alkali. So let's look at what they've done here. If you will look at this one right here, right? It says 2 sodium hydroxide gives sodium sulfate. What's happening is that all of the H2SO4 is being neutralized. So they want to know, given this volume of alkali, how much acid would you have? All right, if I've got 50 centimeters cubed of your alkali, right, to get rid of all of it, to be able to neutralize just the right amount and get Na2SO4, the acid volume should be half as much as the volume of your alkali. Ratio 1 to 1 है concentration wise. तो volume acid का alkali से आधा होना चाहिए if you want to get rid of again all of the protons. So for 50 centimeters cubed to completely neutralize the acid, you would need 25. Now, for 50 centimeters cubed of alkali to only get rid of half the protons, for half the protons, you would need half the amount of acid as the other one. So, मैं क्या कहना चाह रहा हूँ? अगर यहाँ पे 25 हमने डाले हैं कि हम पूरे एसिड को एल्कली से न्यूट्रलाइज करके सॉल्ट बना दे सोडियम सल्फेट. इसका मतलब है कि अब हमें इधर और मजीद कम एसिड डालना पड़ेगा कि हम सिर्फ आधे एल्कली या एसिड को न्यूट्रलाइज कर पाए. This is why you would end up getting NaHSO4. Hey, sorry, there was a lot of noise in my background. I was trying to get it to stop. I apologize about that. Let me be a little bit further, please. I apologize. The answer here should be this. Now, let me explain through it again. If I give you 50 centimeters cubed of acid, alkali, and the ratio is 1 to 1, the ratio between the alkali and the acid is 2 to 1. So if I give you the concentrations are the same, for 50 alkali, I need half as much acid for complete neutralization. Now, for 50 alkali, half as much. Now, if I give you 50 and 50 of both, the problem is with 50 sulfuric acid, you should have had 100 centimeters cubed of the alkali to fully neutralize the acid. But you only have 50. So you're only going to get rid of half of the H plus ions, not all of the H plus ions. So if this is what we're looking at, and if this is what we've got, here's what happens when you use 50 and 25. You have exactly the right amount and they cancel out. The problem here is in 50 centimeters cubed of sulfuric acid, this is how much H plus you have. Unfortunately, this is how much alkali you have. So you can only get rid of one of the protons, leaving one of the protons behind. So your answer should be 25 for the sodium sulfate, 50 for the sodium hydrogen sulfate. A is your answer. All right, 36. Octane is an alkane with 8 carbon atoms. First things first, it said alkane, so you should be thinking CnH2n plus 2. A and B are out. C and D are your answers. Then it says, all right, compare octane to a carbon that has, it said, compare that with the boiling point of butane, bute meaning 4 carbons. So if octane has 8 and bute has 4, octane will have a higher boiling point than butane. So your answer is D. All right? D will end up being your answer. All right, 37. The The monomer given here is but2ene. It says it can be used to make an addition polymer. It says this addition polymer has a chain of carbon atoms joined to each other by carbon-carbon single bonds, right? Each of these carbon atoms is also bonded to at least one other atom or group of atoms. These are called side groups. So let's talk about what's happening. This is your monomer, right? If I give you an n number of this is the polymer that you will get, right? So each of the carbons right here, it said in the chain, is now going to be joined by carbon-carbon single bonds. So it wants to know which statement describes the carbon atoms in the polymer chain made from this monomer. A says each carbon atom in the chain has one CH3 and one hydrogen atom as its side groups. That's your answer. You don't need to go any further. It says that each carbon in the chain is joined by this. That's wrong. You have a carbon with a hydrogen on one end and a CH3 on the other end. See, every carbon atom in the chain is joined to two other. That would mean that's what that would imply. We can see that that's not the case. So B, C are both incorrect. B, every carbon atom in the chain is joined by hydrogen atoms only as side groups. That is not true. This is, by the way, only true for polyethylene. That's the only polymer where each carbon of the chain would have only hydrogens attached. So the answer is A. 38. All right, first things first. Whenever you want to name or determine what the monomers are, first break the actual bond. Look at the ester bond. Look at it very carefully. Remember that this C double bond O is always coming from the acid end. So the acid end has two carbons, and the alcohol end has one carbon, right? So if the acid end has two carbons and the alcohol end has one carbon, what that means is that you can deduce the name by using, again, the idea of attaching the prefixes of the alcohol and the acid accordingly. The first part of the name always comes from the prefix of the alcohol, so that's methyl. The second part comes from the prefix of the carboxylic acid, which is ethanoate. So the compound would become methyl ethanoate, or C would be your answer. 38 is respectively C. All right, 39. The partial structure of a polyamide is shown. Some of you may have been able to get this answer very quickly because some of you remembered that, again, technically, other than protein and nylon, there's no other amides on your syllabus. But here's the point that's most important. If we're going to break the amide linkage, that's what we would do. And then we would recreate an OH here and an H here, right? So the actual monomers would be amino acids. And unfortunately, that's not two, that's not three. So the only choice here is A, one only. The only monomer that shows an amino acid is choice one. Again, just so we're clear, if this had been alternating linkages, you see the same linkage throughout. Had it been alternating linkages, then you would have gotten a diamine or a diacid. But because you see the same linkage, the same orientation through, it's an amino acid. Okay? All right. Question number 40. Which compound is an alcohol? Through another very easy one in there. The only reason that was slightly difficult is it was a double alcohol, but it didn't matter. It said which one's an alcohol. So the only thing that can make an organic compound an alcohol, beta, is if somewhere on its hydrocarbon chain you happen to have an OH functional group. That's the key. There's got to be an OH. And the only choice that has one OH, or in this case, two OHs, is choice B. All right. So again, I hope that this was a little bit helpful. This will be, I think, posted as the Triber said, onto the group as well as a video. So if you want, you can go onto YouTube and it will be available. Again, I hope that some of the tips and traits helped you a little bit?